Legacy app modernization, when to rewrite, refactor, or replace. So, legacy app modernization. It's something a lot of people ask about, and today we're going to walk through it step by step. Let's talk about next up, the 3 paths in legacy app modernization. Legacy app modernization doesn't mean rewriting everything. It means choosing the smallest intervention that removes the bottleneck. The right option depends on codebase age, business criticality, and how differentiated your custom logic actually is. If your core business logic is sound but the code is unmaintainable, refactoring with modern ASP.NET patterns can cut maintenance costs by 40 to 60% without the disruption of a full rebuild. A structured ASP.NET development services engagement typically starts here: audit what works, modernize what doesn't, and introduce CI/CD around what you already have. The second benefit people underestimate is team confidence. When developers fear a codebase, they slow down and make conservative choices. A refactored codebase that engineers actually understand changes velocity more than the architecture change itself. Rewrites fail at a startlingly high rate because tribal knowledge about edge cases, compliance rules, and integration quirks lives in the old code. When you discard the codebase, you lose that knowledge too. Rewrites are warranted in specific, diagnosable circumstances, not as a default when the code feels difficult to work with. Now, how to know when to refactor your existing .NET application. Refactoring works when the fundamental architecture is sound but the implementation has accumulated years of shortcuts. Think of it as fixing the plumbing without demolishing the house. The clearest signal: if your developers can explain what the system does in 10 minutes but complain that changing anything takes 3 weeks, refactoring is your answer. The domain knowledge is intact. The code quality isn't. For indicators that refactoring beats a rewrite or replacement. Now, when a full rewrite actually makes sense. Rewrites are warranted in 3 specific situations, and most teams choosing them aren't in any of those situations. Situation 1, the architecture cannot support required scale. If you need horizontal scaling and the app has hard-coded database connections and global state throughout, refactoring won't get you there. You need a new foundation. Situation 2, the technology is genuinely end-of-life with no migration path. Some older SOAP-based services built on WCF with Windows-specific dependencies cannot move to modern .NET without being rebuilt from scratch. Let's talk about now, when to replace, buying instead of building. The buy versus build decision is where enterprise teams often have the most emotional investment and the least objectivity. A system that took 3 years to build feels worth maintaining. Sometimes it isn't. Replace is the right call when all 3 of these apply. Your app does something 50 or more SaaS vendors also do, the total maintenance cost exceeds the SaaS subscription by 2x or more, and your team spends more time keeping the app running than actually using it. For most standard business processes, a custom software development company will tell you honestly, don't build this, buy it. The fact that your process has some unique quirks doesn't mean a custom app beats a well-configured off-the-shelf product. Moving on to the Strangler Fig pattern for .NET application modernization. The Strangler Fig pattern is the most practical approach to large-scale .NET application modernization, and the one most often skipped in favor of more dramatic options. The concept comes from Martin Fowler's original work on incremental migration. You build new functionality around the edges of an existing system, gradually replacing components until the old system is gone. You never flip the switch. Legacy .NET Framework modernization uses the Strangler Fig pattern to incrementally replace components without a full rewrite, so each delivery cycle produces working software rather than work in progress. In a real .NET modernization engagement, the process looks like this. Let's talk about what .NET 9 migration changes about this decision. Performance data from .NET 8 and .NET 9 shifts the ROI calculation meaningfully. Benchmarks from Microsoft's .NET Performance blog show 20 to 40% throughput improvements in web workloads compared to .NET Core 3.1 baselines, with particular gains in JSON serialization and HTTP/2 handling. An application handling 5,000 requests per minute on .NET Framework might handle 7,000 or more on .NET 9 with the same server footprint. For teams paying per core cloud hosting costs, that translates directly to monthly savings. If you're also moving to Azure App Service or Azure Kubernetes Service, the performance gains compound with autoscaling benefits since you need fewer instances for the same load. The technical work splits into three categories. Now, microservices versus monolith for your modernized .NET app. This is the architecture decision that generates the most heated debate in .NET modernization projects. The honest answer is that most teams choose microservices when they shouldn't. Microservices make sense when you have multiple teams working on different bounded contexts, highly variable load on specific components, or genuinely independent deployment requirements. They add significant operational complexity, service discovery, distributed tracing, inter-service communication patterns, and a much more demanding CI/CD pipeline. For a team of 5 to 15 developers on a single product, a well-structured modular monolith is almost always the better answer. Working with a .NET microservices consulting team makes sense when you can answer yes to at least two of these. Let's talk about next up, what legacy app modernization actually costs. Here are realistic ranges from mid-market and enterprise engagements. Engineering costs only. Hidden costs are in the next section. These ranges assume a dedicated team of 3 to 5 developers. Larger applications or more complex integrations push toward the upper end. Before committing to any path, a formal compatibility audit for the refactor or rewrite options typically costs $5,000 to $15,000 and regularly saves 10 times that in avoided mistakes. The numbers above cover engineering. They don't cover. Let's talk about conclusion. Legacy app modernization doesn't have a universal right answer, but it does have a structured decision process. Start with the least invasive option, refactor if the architecture is sound, rewrite only when you can articulate a specific reason refactoring won't work, and replace when you're building something SaaS vendors already do better. For most .NET shops, combining .NET 9 migration for performance gains with the Strangler Fig pattern for gradual component replacement gives you a path that manages risk while delivering value throughout the project. The biggest mistakes happen when technical ambition outpaces business need. Q Services specializes in .NET modernization with human-in-the-loop governance for enterprise applications, meaning architecture decisions go through structured review before any significant commitment is made. If you're evaluating your options, our .NET Development Company Buyer's Guide covers what to look for in any modernization partner. Reach out directly for a scoped assessment of your application portfolio.